Hey everybody, this is Larry. This is me going over Q4 of the bi-weekly contest 69, Stamping the Grid. Yeah, hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem. I spent a long time on this problem. I would say this was very hard for me. I did learn something from this afterwards, so we'll go over what I think the intended solution and a solution that a lot of people have done. But I am going to go over my solution first, and one thing that I do want to, well, two things. One is that if this is a little bit slow, fast forward, do whatever you need to do, skip ahead. You have the technology, I believe in you. Then the second thing is what I want to, why am I going over a suboptimal solution that I will, but I did get it accepted during the contest. It took me, let's see, it took me literally an hour and 3 wrong answers. A couple of them were a little bit silly, but still. But I want to showcase, and you could watch all of it live. Maybe you don't have to, but you can, and kind of see my process during. But I just want to highlight, sometimes you just have to grind it out. You just have to work it out, and if you really want to, if you watch it on like a faster speed or whatever, you'll see that like I tried a lot of different things for this problem. There's something that I just didn't. Maybe I don't know if I know or I knew. So this was something that's new to me, or new-ish. I have used different techniques in this before in a different way, but I didn't have the visualization necessary for this problem. And we'll go over that in a little bit. But like I said, I'm going to go over my solution and then kind of, and just know the win that I want to highlight is that, like, look, sometimes you just have to keep on grinding, keep on working hard, and maybe you get, like I wasn't, like, this could still be wrong, right? Like, but that's fine. You just keep on trying the best that you can and keep on grinding it out. And even if it's not the intended solution, even if it's a little yucky, even if it's disgusting, and actually my code is 146 lines and it's not as clean as it is usually. In fact, there are a lot of cases where I could have even refactored the code to be at least shorter, which I didn't do. And actually that cost me, did that? No, I mean, okay. I mean, yeah, that might have cost me a wrong answer, at least some time debugging as well. So yeah. So I want to kind of highlight, so even I am not immune to kind of being lazy, but every time I get lazy, I get penalized for it. So that's why when you see these, when you see someone writing clean code, it's just a lot of experience and kind of thinking ahead, like planning that out a little bit, right? Okay. So that said, I am going to go over my algorithm real quick. And the way that I'm going to do it is by drawing. So give me a second to pull up the paint tool. The way that I did it is actually with something called sweep line, or line sweep. Let's see, let's copy this image. Oh, that's a little bit big, actually. Can I shrink this? Don't know how to shrink this. Okay, fine. But yeah, let's just say we have a grid and then we have some x's. It doesn't even have to be like, whatever, right? And then the idea is that you're trying to figure out, if this thing is possible. And the way that I think about it is try to find a case where that is not possible. That's the idea. And I went into a couple of cases where I was wrong, but the first thing that I tried during the contest, I'm explaining everything so that you could kind of see my thought process and my evolution, and not just like the solution, even though it's a weird solution, but it works. It's a little bit slower, but like I said, it works, and I'm happy that that happened. Yeah. So then the idea is that, okay, so my first version is just looking at axis aligned things, right? So here I look at every, so for every 2 x's on the same row or column, right? So I just basically look at the space in between, right? And then in this space, obviously if it's smaller than the width or the height of the stamp, then it's false. Let me actually redraw this in different color. Hang on. Right. So I think this part, you can kind of reason it. It's a little bit greedy, and of course, we would also have to factor in, you know, the number of spaces to the edges, right? So that's pretty much my first iteration. I submitted it, and I got a wrong answer. And why did I get a wrong answer? And I got a hidden input wrong answer, so I didn't know how to resolve it. And the idea is that is something like this, right? Where my solution could be wrong for something like, okay, let me now draw this out, because now I could delete this. Hang on. So something like this. Let's say that our allowable box, and I'm going to take another color, is something like this, right? Maybe even this. I don't know. It doesn't really matter, right? But here you can see that with our original constraint. Let's pretend that this is enough space. We have enough space on the borders. You could just keep on adding empty spaces. So let's pretend we have that, and we're focusing on the middle, right? So here, this X, you can see that for every X, this is true, that you can go up, down, left, right, and there's no nearby thing. But if you put your stamp such that it is the cyan color, it won't fit, right? So what that means is that, like, this is false, even though I will return true. So how did I resolve that? So the way that I actually end up resolving this, and like I said, it took a lot of time, so I know that I'm saying it really quickly, and you're watching this video, and it's pretty quick. But like I said, there are different ways of doing things. So the way that I've thought about it is with sweep line. So the way that I thought about it is that, okay, right? Let's say I have this X, right? I have this X. So then now what do I do? So now I have the same logic as before, kind of, but now I impose imaginary X's that is down the all the way down, right? So then now, and here, I would have, you know, just focus on the down. So I just focus on the down, and you know, dot, dot, dot. Let's pretend that we have enough space, right? So here, it's all this stuff as well. And then that's basically the idea for my algorithm, is that, okay, I mean, it's not, I don't draw all the X's physically, but in terms of you know, and we'll go over the code real quickly, but in terms of, like, virtually, that's what we do, right? And then now we're able to go from and why we call sweep line is that now we have, let's say, you know, this sweep line, you know, we have this line going in this direction, going from you know, up to down, and then now let's say we sweep here, right, under here, on I guess technically it will only things only change when you add or subtract. So let's say you go here, right, and then here now we check to see whether there are two adjacent X's, and if they're too small, then well, by definition that just would not, like, you cannot create anything that's in between this area, right? So that's basically the idea behind how I did this, and you can also imagine that for without explaining further, you can imagine that we flipped it so that now we do, you know, going from left to right, and the X's are from left to right to kind, and your spaces are vertical. I mean, I trust that you're smart enough to kind of generalize it on the other dimension, but that's basically my algorithm. Yeah. And we'll go over the other algorithm next, but we'll go over this code first. Yeah. Let me find my code. Let me also take this off for a second. But that's basically my algorithm, is combining those two. It's way yucky because of the way that I evolved it. The code is disgusting. Would not recommend it. There's a couple of optimization, or not even optimization, just code way to make it cleaner. But I'm being honest, this is my contest code. I'm trying to solve it as soon as I can. I solved it only about 15 minutes before the end of the contest. So I was like a little bit rushing it, and I wasn't even confident about this, to be honest, during the contest. So that if I was wrong, I have more time to figure it out. But it did cost me a wrong answer because I did have an off by one somewhere. But this is basically similar to the events-based sweep line that we talk about. This is actually not necessary. I actually could remove this because I think originally I had another idea relating to like the largest rectangle in a matrix or something like that. So let's remove it. Actually, I don't know. I hope it doesn't time out during the whatever. But yeah. But basically, I have two algorithms that I kind of combined together, so it's a little bit yucky. But basically, this is looking at the event based first. We set up the events on the x-axis and the y-axis, and for that we set when it enters and when it exits. Right. This is very similar to even the problem from a couple of days ago on the daily challenge, the call pulling problem, where you have like, okay, they insert and add, right? So that's basically the way that I did it here. Yeah, so on row X, we add a new column Y, and then on row X plus stem height, because that means that now we could fit in another stamp at that height. We remove the column Y, which is why I have a -1 here, right? We do the same thing for the other dimension. I'm not gonna go over it. It's just exactly the same, but for the other dimension, right? Yeah. And then here, and I'm only gonna go over one dimension because, like I said, it's the same for the other dimension. And I copy and paste here, which is not good practice. But yeah. But basically for here, so there is a little bit of a nuance here that I did, which is why I did it this way. The idea is that, okay, let's say, this is a little bit tricky actually. Let's say you have something like this, and you add, let's say you have, okay, actually, yeah, maybe this is an easier example. So let's say you have something like this, and there are a lot of, let's say we have infinite dots to the higher and below or whatever. So then the reason why I had to do it the way that I did it here is that if I check for, when I'm up to this row, let's say I'm up to this row, when I add this X, at the time, we think that the board looks like this, or worse, because of this X, we think that the board looks like this. So then now we think that there's 3 space in between, and that we need to fill. So it will return a false if you had like if you need more than 3 spaces. So what I needed to do was actually process the entire row, or we add all the rows together, and then we process each row one at a time. So that so that there are no gaps in between that we need to fill. And that's basically what this. Why do I have? I think I accidentally left some print statements in here. Actually, that's pretty bad. Actually, because oh no, I mean it only returns once for each problem for return false, so it's okay. Otherwise, if you return or if you print too much, you may get a time limit just because you're printing too much. Hopefully that doesn't bite me in the butt during the post-contest things. But that is a thing that we have to worry about. Yikes. Like I said, I'm very sloppy today, and this is very yucky code that I'm only looking at now. But yeah, so that's why I do this, where, okay, if we have a event where we add, we basically just add it to the things that we have to check. We add it to the current list, which is a sorted list that I maintain. And then now if we process a new row, basically if the previous X is not X, then we have to process a new row. And if we process a new row, then we look at the sorted list. Basically what we're looking to do is that we're given an array, essentially an array of X's. And we know that we want to insert here, for example. And if you're inserting here, then the question is, okay, how many spaces is there to the left and to the right? And that's basically what I do. So there are only 2 possibilities, or there are a couple of possibilities, but 2 possibilities of being wrong is that if there's too much space, but one edge case is that there can be one right next to it, right? If there's one right next to it, that's fine because there's no space to fill, so that's good. So yeah, so that's why this if statement's a little bit awkward. Is that okay? If there's at least one space that we need to fill, and but if the less than stamp with to fill, that means that we can squeeze it in, then this returns false. And also this is just looking right and this is just looking left. That's basically the idea here. And then once both is done, if it's not possible, we return false. And then of course we now empty the set that of the numbers that we have to check. Yeah. And then we do it for the other dimension, so I'm not gonna go over it right now. Or like it's the same, it's just, instead of going from left to right, you go up to down or the other way or something like that, right? Down to up or up to down, yeah. And then here, I just look at, for axis align, I just look at adjacent widths to see if they're good. I probably could have squeezed it into the events thing, but I, I evolve this one bit at a time. So that's basically the idea. Yeah. What is the complexity of this, right? So there is a sorting here on the X, so this is going to be depending on how many objects there are. But of course, the number of objects in the grid, like they're all ones, could only be 2 times 10 to the 5th. So this is going to be technically O of R times C times log of R times C. But there is like some, like it can get too big. So this is on the sorting, and here it's the same in that, for each item, for each X, like for each blocked area, you're gonna do a binary search on at first the longer length, which is the longer length can be at most 10 to the 5th. So if you do one of those log n searches for each, it's not a big deal. So yeah, so that's basically the idea, is that on one of the dimension, for example, this is O of R times log of C, I think. It's a little bit yuckier because I don't dedupe, so I could have done a little bit better on this, but with a constant, so that's basically it. And then for the other dimension that I didn't show, it's going to be C times log of R, and then the other thing we hear is just linear, so I'm not gonna go over that. But yeah, so that's basically the algorithm is this thing. And of course this all combines to be 2 times 10 to the 5th times the log factor, which is fast enough for me, hopefully, knock on wood, during the contest. Yeah, so that's the way that I did it. I wanted to go over it in detail, just to show, like I said, like the different ways of doing it. And if you have seen other code, and I'm gonna go over other code, we'll go over how to think about it, and then we'll go over other code next. But I just want to show you, like, it is possible to come up with different algorithms, even though it's a little suboptimal. And it's possible to do it even if it takes an hour. I would say I'm not familiar with the other technique, though I've done it in 1D before without knowing it, with visualization. So I did this. So I have used this technique before with different visualization, and we'll go over this with the paintbrush back on. But yeah, let's for a second, let me clear this, of course. Let's for a second think about this in 1D, right? Let's say we have to do it in 1D. What are we doing? Well, the idea if we have to do it in 1D is that, okay, let's say we have some blocked areas, right? Let's say this is just a number line, and then let's just say, for example, this is blocked, and this is blocked, and this is blocked. I mean, of course, there are easier ways of doing it. You just do a linear scan, but let's pretend that we have to do the math now first, right? So the way that I would do it is that, let's say we have a 1D stamp as well of width of what X. So then here, the idea is, is that, okay, let's say we have, let me change the colors. Let's say I have a stamp of length, let's just say this, I don't know, right? And then, so the idea is that we try to stamp every place that we can. And the way that we check it is with a couple of things, but okay, let's say we're able to stamp here. So then now this is just, yeah, we're trying to figure out way to stamp it, so it becomes an and we stamp it in any possible way that we can, and then it becomes an interval overlap problem, right? So for example, let's say we have a length of this. Let's just say we could squeeze it in here for now. We have an X, so we can't do any more. So then we have a second one that's the same length, and then one space over, one space over, one space over, and then we reached X, and then now, I mean, I'm not going to draw all of it, so let's pretend, dot 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 dot, right, all the way to this X, right, and of course assuming that they're the same width, right? I mean, my art is terrible, but you get the idea, right? So now you have all these segments, and you're trying to, calculate. I mean, you don't have to calculate the exact overlap, but you make effectively like a Boolean overlap, right? Because now you can see that combined, this has like one line, this has one line, and of course, and so forth. And I failed a little bit here because let's say that there is, let's say for a second, this doesn't fit. I mean, just play with me, right? So that, so if everything fits, then, you have these combined lines. But if everything doesn't fit, now we just check one space at a time of, okay, is there a possible segment here? Yes, yes, no, and then now we return false. So that's basically the idea behind this, the 1D version, right? And then, and of course, there are a couple of techniques here that I kind of skipped a little bit. The question is that, okay, if I want to, let's say I want to try to stamp a length of this thing, right? How do I check whether I can do it? And the answer is with prefix sum. I'm not going to go with prefix sum in this video because it's already a long video, to be frank. And I have a lot of videos going over prefix sum, but basically you just calculate the number of x's to the left of this, point, and then you calculate the number of x's to the left of this point, and if there's 0 x's in the difference, then you know that there's 0x, so then now you can draw this line. And in the same way, let's say you have here and you wanted to draw it to here. Here there's one, the answer is there's 1x to the left. Here there's 2x to the left. So then that means that there's 1x in the middle, so then you don't draw this line, right? Okay. So yeah, so that's basically the idea behind the visualization behind this concept, and the way that you can kind of solve this. Let's say that you already used the prefix sum to draw it. The way that you're able to calculate this is just now you do this thing called what I call line sweep, or sweep line, or as a visualization, because for every point we can just add, okay, for here we go +1, and then here we go -1, right? For every end point and starting point, and so forth, right? Dot dot dot. And then now here, so then here, now that to draw this line, let's say we started from here. Here we change to, there's one line segment here. From here, there's 2 line segment, dot 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 dot. Here there's subtract 1, so then now it's whatever it is, -1, so like, I don't know, k -1. And then here there is k -2 and so forth, because now you're subtracting line segment. And then now if you pre-process this, you're able to see that when you do this check that we did earlier, similar to here, when we do this check, we just check that there's at least one bit in this, one element in, or if this is non-zero, then we're good, right? Because if this is a 0, then that means that like in this case, then that means that it's not possible. Then you return false. Okay. Sorry, let me catch my breath for a second. I do believe that now we explained all the concepts that we did in one dimension. Of course, for this particular problem, it is in 2 dimensions, so we just have to kind of think about it in a 2-dimensional way. So then now, for the prefix sum, let's draw the thing a little bit. So now let's say we have this, and then we have some x's. And this is a problem that we've done before, the 2-dimensional prefix sum. So I'm not going to go over it too in depth, but the prefix sum portion could be solved by asking, okay, let's say we have, let's say we want to try to figure out how many x's are on this. Well, the number of x's that are on this in the 2-dimension is just equal to the sum of this prefix of the number of x's here minus the number of x's here and here. But of course, now we subtracted the upper left corner twice, this corner. So then now we add this back on, right? So then basically we add, yeah. So that's basically the idea, is that, okay, you add this back on, but you subtract the purple component, which is harder to tell now. And yeah. Like I said, we've done it before, so I'm just kind of giving you a quick visualization of this is how you calculate how many x's are in this part, by subtracting this part and this part, but then we add back in this part. Yeah, hopefully that makes sense, and that's how you get prefix sum. And then now you just ask yourself, okay, now I'm able to because if you don't stamp it, you just move on. But if you are able to stamp it, meaning that there's no x in this circle or this rectangle, really. So let's say there's no x's here. Then you put a stamp in the same way that you do earlier with by saying that, okay, yeah, having a difference away by here. When we were pre-processing, when we did this x, we pre-processed an event that is on this vertical and this horizontal, and then you kind of just remove it. Yeah, you remove it later on. Almost the same as the same idea as before, right? Because we're now drawing a line, a box from here to here, and we want to draw that. Basically, like, you want to draw a virtual, let me do another color. This is getting a little bit messy, but yeah, you want to draw a virtual box that's like, here, dot, 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 dot. And that's basically the idea. We'll go over the code now, but that's basically the idea, right? And for here, I am stealing numbers code. Check out his YouTube video, but you might even have a good or a better explanation. But yeah, but that's basically the idea behind this one, is that basically you have a prefix sum array, which is what you have a prefix sum array. I write this a little differently, but this is the prefix sum array. And then now for every rectangle, we check to see whether it exists. If there's no x, which means the sum is 0, then you put it in this these sweep line things like we said before, and then now you kind of just go over. There are different ways of doing this sweep line, but this is the way that he did it. But basically, this is saying that, okay, now we begin an endpoint here, we move an endpoint here, and so forth. Yeah, and then here we just basically in 2 dimension calculate what we said, like the overlap, right? And if the overlap, if there's no overlap at all at a certain space, and if the original grid does not have if it's not blocked off, then you return false. So yeah, so this is a very much straightforward answer, and of course this is going to be O of R times C, and in time and space. So yeah, that's pretty much all I have for this one. Hopefully the visualization helps. This is a very tricky problem for me, because I didn't really think about it in this way. But it is something that I am learning, so I am pretty excited about that. Even my rating takes a hit. But yeah, that's what I have for this one. You could watch me solve it live next. Maybe watch it really on a fast speed. Like I said, the one thing that I do want you to get out of it is not necessarily the algorithm but that just keep on working on it, keep on grinding. There's different ways of doing it. Even if I didn't know this thingy, but I was still able to kind of figure it out. So yeah, that's all I have for this one. And yeah, watch me solve a live in contest next. Maybe not. Yeah, okay. Try to be more strings it, but 2 wrong answers is silly. I'm really needed more sleep today, maybe. Okay, let's figure out this one, which someone already solved. So many constraints. Okay. What's going on? Okay, so we have 4 by 3. Okay. 2 by 2. No rotate. Can overlap as many as we want. Okay. I mean, this is just like a prefix something, but I don't like a 2D binary index tree or something like that. That's just like annoying to implement. Is that true? Yeah, okay. I'm sure someone like Leetcode would have it ready. Maybe. I don't know about I'm right about this one. Okay, but think about what's impossible instead. Can we put it in the statistics system? It's like a maximum square. If this was a square, this is easier, but for rectangle. Yeah, I got a lot more people have gotten it. I don't know if I know how to do it though. And I'm really behind because of the 2 penalties. But, so thinking about the impossible cases a little bit better, but let's see. If there's an X that is near the border, maybe? No, that's not true, because here you could do it or, but mm, 10 to the 5th is pretty high though. But this thing has to be noted. So basically, if I think if we just chop off the corner and then just test for the corners, it should be okay. Yeah, maybe that's true. I don't know. This. Oh no, that's not good. I mean, that is one impossible scenario, but there may be a case in the middle as well. How do I test in the middle? Okay. Or is there a case where it is impossible? Well, it's impossible if there exists like if two things are in the same row or column. If two things are in the same row, yeah, I think I have an idea, but this is still a very ad hoc problem again. So, the stamp length have to be smaller than this? No. Okay. So then we do want to do something like, we do want to set as a default, set something as a default, don't we? I guess technically like a one. Let me see. Is this if This is so on. What was the other? Okay. I could have deduped this. Well, that's not good. Oh, I have to. I did remember this, but because 0 is okay, because there's no space in between. Okay, well that didn't work out well. Why is that? Oh, I guess technically if there's 1. True, that's not. Oh, that's not good here either. But 1 exists. No, it's 2. So if I just have off by 1s. Alright, well here goes nothing. I'm not very confident about this at all. But I also have no idea, so let's see if this gives me a good idea. Some test case. Hopefully not a big test case. Hopefully not a hidden test case. Oh no. Hate the hidden test cases. I guess if I have to guess, this is probably a little optimistic, that's why. And there is another way of impossibility that isn't aligned. Yeah, I know a case where this isn't true. No, is it? Now I know a case where this is not possible. Okay, so I know my wrong answer. But how do I address it? Yeah, I made a wrong assumption here. How do I even begin to fix it? Don't know, maybe I just don't know this one. have an hour left, is that it? Wow, 588, wow. I mean, that's surprising, to be honest, but because of the penalty. But this was a really weird contest anyway. Okay. How do I get the case word? Never mind. Maybe I don't know, so I'll just think. A lot of smart people done it. I don't know this one. It's a 2x2 game of confidence, so the thing that I have, so we have a 3x2, and we have something like 2. Okay, so this is one case where the 3x3 won't work, but my algorithm thinks it's true. How do we solve this? So, can we check for every space? Every space, what does this mean? This means that there exists either in some diagonal. I don't know how to do that in fast time. Maybe I do need a I'm just looking up 2D binary index tree. It's been a while since I've needed it. I don't know if that helps, to be honest. Because that still requires us to update everything if we want to throw something in. So, which is, I don't know if that's good enough. Because that could be like really fast or really slow rather. So okay, so this part is true. So maybe so that eliminates it, but we still have these cases. How do we do it? It just kind of remind me of that biggest rectangle problem, maybe. Can we do something like that similar biggest rectangle here? Doesn't have to be in any of the corners, right? So here the biggest rectangle is 4, but I don't know if that means anything. Can I do some sort of DP of let me look up that problem. Largest rectangle in histogram. There's another one though, right? Maximal rectangle. I use the same principle here, but it's still R times C, which I guess that's fine, maybe, because of this thing. I guess it's this is a hard problem, but I think I have an idea, but I don't know if it works. How many people done it? 41. But the same idea there of okay, for every row. We see whether this is one of the things that I am weaker at. Let's try it. This is from my maximal rectangle code, so that's why it looks a little weird, but this is my thingy code. How do I adjust it? Because this is the highest, which is not true. What we want is if that's not the case, then what happens? Then else if tell this how do we think about this? We really only for each row we only no, that's not true. I mean, this is true for getting the biggest one, but I have to try to figure out how to see if we could fit in everything. And okay, so I guess here this code already does the edges, so here we just have to try to figure out the inner stuff. Is that right? What if it's too small? Then what happens? I don't know that I know how to do this. How do I handle this case with a 3 by 3? Yeah, I don't know. I don't know this one, maybe. I have another 40 minutes though. I don't think that this makes sense, maybe. I am missing an observation. Yeah, because of the maximum rectangle, it's whatever, but I know that this square is not possible. I don't, guess I'm just really off today. I don't think this makes sense, but this thing is fine, but sweep line, right? does it mean for a sweep line? Is that from here? So we have something like this. Okay, and then now so by X, so then now we're going down, and then okay. This isn't quite right. What I want is actually maybe off by one, that's fine. Going down X. Yeah, okay. I know I didn't do the other one. I just want to see if this compiles at least and doesn't break anything. Okay. This is where I should have used better abstraction. When you copy and paste. But that should be still right though. I don't get it. Well, I don't know if it's right, but it should give me the same thing. 84. Oh, whoops. Let's give it some. I don't know. This is probably wrong, but we'll see if we at least get as far as before. So this is actually worse than before, but because before we got to the hint cases, this is not debuggable. In fact, expected true, but I have false. Why did I have false? Oh, no, this is right in theory. Unless I messed up this and this. I don't think this is right. Oh, I know why. Because no, that's not true. This should be true, but I'm returning false. Why am I returning false? Okay, so it's in this. Hopefully it doesn't print out too much stuff. Okay, it does print out too much stuff. Is that right? Oh, we just ran out of characters. This isn't quite. Okay, fine. This is also a little bit awkward, but that's fine, maybe. At 398. I mean, this is an impossible thing to just look at and be like, oh yeah, because it's just hard to visualize. Slightly better visualization, but okay, so then we have this. And then it runs up space, is that it? Yep. Need to run this locally maybe, but hmm. 493 is X. Did I just have an 051? That was something that I was thinking about, but no, still wrong. $98. It's ridiculous. Oh, I see. Because of this thing. Okay, I see why this is wrong, but because I see. Because of this thing, but because we add it in a weird order. How do I handle this then? 25 minutes. This is conceptually right, but I don't know how to check this part in a good way. Okay. Because now this is too far, but what would you want? Delay this until later. How do I delay this until later? Ugh. Okay, nice. This is fix at least this issue. Well, now the y is in it, right? So we have to this is this part is y, but this one is should be I mean it's a little bit awkward, but it's the hand I'm dealt with for now. 79. Why not tell me why? Like we did nothing here. Should still work, right? Okay, so then I'm doing something funky. Oh, I changed y. That's why. Okay, this is still returning false. Why? Why is that? That shouldn't fix it though. Why is this still wrong? Oh, this goes off the grid. Though, shouldn't really matter the off the grid part, but I put it in the wrong place. What? Where am I returning false? In the X. Okay, so I guess I resolved it for X or one direction, but then I didn't do it with the other one. Which is, I guess, good. Okay, so that's good, maybe. But this is such a yucky thing. I should have. Yeah. Well, it's too late. Maybe it's not too late, but whatever. Guess I could reuse. Oh no. Maybe it. Oh no. Let's have a check 482. That's fine. I'm checking 482. And then now. Oh, I don't reset. This is where copy and paste is gonna bite you, and it, I guess, did me. What? That sucks. This is where also copy and paste is getting me. Okay, 119. Impossible state. This is copy and paste silliness. Why? How? So not in list. Why? Oh, because this is 1, so then I see. That's actually a cute thing. Maybe I didn't need this though. I wasn't sure. I think I just can't put it in, to be honest, because I confused myself a little bit. Yeah, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's contest. I didn't do so well, but you know, maybe you did better on this problem or whatever. But yeah, stay good, stay healthy, take good mental health. I'll see you next problem, and bye bye.